Mr. Azril Amir Jaafar, the Principal and Director at VERITAS Design Group. Mr. Azril is an architect with an experience of over 20 years with special interest in environmentally sustainable design solutions. He is a Principal and Director of VERITAS Design Group, one of Asia's largest design firms with headquarters at Kuala Lumpur, an IATA certified airport terminal planner and designer. Mr. Azril has been involved in designing low-cost carrier air terminals and airports in Malaysia. Today, Mr. Jaafar will speak on airport terminal from the sustainable design perspective. Let's welcome Mr. Jaafar.
Right. Okay, first of all, just now the introduction says that we are based in Kuala Lumpur, and we also have offices in other part of the world as well. And my India director reminded me before the session not to forget mentioning that we have office in Mumbai. So yeah, so now we have office in Mumbai as well. Right, basically, as mentioned, I tried to look at this presentation from a slightly different angle, from kind of like more mass, I think mass travel mode kind of angle. For example, okay, when you look at the picture, the first picture that I showed on the screen now, it is a picture of a Boeing 747 upper deck, probably in the 70s or 80s when it was introduced to the market. And it shows, I think I cannot see over the whole screen. Okay, anyway, it shows what air travel is all about in the past. It is about the luxury, it is about for the upper class society, and probably it is too exclusive, and perhaps it is quite rigid. You know, you have to wear a certain way, you have to dress a certain manner to be on the plane in the past. Right, nowadays, the air travel is become kind of like a mass transport in certain countries. It is become kind of necessity rather, and it is for the masses. And it is more inclusive and quite flexible, actually. Okay, let's see the next slide. Okay, when I talk about, the airport being, the future airports perhaps is to cater for everyone. It is to cater for the masses, especially, the big country like India, where a lot of people need to travel from one state to another. I think that is quite valid. Okay, so the airport has to be more affordable in terms of the operation and running, and it has to be, of course, environmentally friendly. And one of the way, perhaps, do a kind of like adopting a sustainable approach. Right. What is the sustainability, elements of sustainability in airport design? Okay, I think these are the things that I can think of, and I listed down for this session. First of all, it has to respond to time, users, and culture. The airport 20 years ago may not be the same now because the aviation has changed a lot since years ago. Even aircraft preference has changed. 747 used to be quite preferred in the old days, but nowadays nowadays airlines are looking into smaller planes, right? That also affect the airport design, and it has to fit to context and climate. You can't simply plan different design or generate design in certain countries. It has to be dedicated for that particular location and countries as well. Okay, and as well, of course, related to climate, it has to, we have to consider the prudent use of energy and resources. It can be luxury, but in a practical manner. And the most important thing is simple yet flexible, because you don't really build airport every now and then. But then, but in the industry changes quite frequently, so that the building itself, the space itself has to be flexible to adopt whatever the changes. And then, of course, practical. I think a few panels mentioned about practicality of the airport design, and it has to adopt automations and innovations. This is one of the important component in the airport design, automations, because of it involves a lot of process, as well as innovations in terms of the operation. And one of the sustainability factor in the airport design as well is the self-generating revenue, because airport is kind of like, to a certain extent, become a commercial center that need to be, to be sustainable in itself. Right. Let's look at the element, because I will focus on the low energy for this session. The first graph here, the first chart here, this is about the energy usage for the overall airport compound. Terminal building takes up about 70% of the energy in the airports. The rest are like, for parking, firefighting and others, but terminal takes up about 76%, meaning that if you can tackle this part of energy, you are saving quite a lot. Okay, and when you look at the terminal building itself, earlier I mentioned about HVAC, because HVAC air conditioning takes about 68% of the energy consumption in airport. The other part, the lighting, take about 17%. These are the two components which is quite heavy user of energy in the airport. 12% probably other things, people mover and all that. Okay, so I listed down the design strategy when we are designing airport, perhaps. First of all, the concept design. You must have the right concept from the very beginning so that the airport can be kind of rooted and memorable. I think Ms. Shivani also mentioned this a few times today. And then you have to identify the energy hungry components, like I mentioned about the air condition, space planning. Space has to be we have to challenge the space planning to make it to improve the condition and the experience. And of course, you have to optimize the natural setting, understanding the climate, the wind, natural lighting, and etc. And another important component is indoor environment quality. Airport in Mumbai, for example, may not feel the same as airport in Beijing. There's something about the airport that become memorable in terms of the indoor environment quality is concerned. And then another thing, of course, optimizing natural lighting, because natural lighting can give a certain character to the spaces. Material, this is another important component in the low energy design. First of all, it has to be really practical and durable, because foot traffic in airports are quite enormous. And the resources, where you source the material, a lot of people mention about getting the local material today, because and that is good approach, because first of all, you give the identity to the place, to the airport itself, and the second is you minimize the embodied energy that constituted in the material itself. Okay, another thing is active interventions. Only add active interventions if necessary. For example, it kind of quite fashionable, I would say, a few years, in the 90s perhaps, to have the people mover, the train within the train within the airport terminal, to link the airport terminal. I think this is something that we have to think about, because first of all, it is a maintenance, and it is also consume energy. And another thing is be innovative on user experience, because when you are kind of like experimenting or exploring different way of designing airport, you have to be aware of the user experience. And another thing is, airport is huge building, a lot of opportunity to harvest energy, renewable energy from solar panel, for example. And of course, I mentioned earlier about the building management system, the BMS, how you place sensors and all that to control the energy usage within the airport. Okay, Right. I just want to share with the audience here about the case study that we did in Kuala Lumpur. This is a low-cost carrier terminal. This is huge low-cost carrier terminal for AirAsia. Well, the main user is AirAsia. It is not for AirAsia actually. It is belongs to Malaysia Airports, but the main user will be AirAsia. Right. It is a 45 million passenger per annum airport, and it is for the domestic, international, as well as a small portion of it for transit. And well, we need to provide about 80 aircraft stands. Right. First of all, we have to understand the model because it is different from the normal network carrier or full service carrier. So it is about flow, move people fast through simplified process, efficient planning, and automation. Because we need to spend on automation, and because this will translate into the higher people turnover, creating volume for concession as well as parking. Parking is another revenue generation element in the airport, and of course, it will create more revenue. Okay, and one of the concept that we explored in this design is simplicity. Airport is a building that you can easily get lost. And basically what we were looking at is back to basic of the airport operation. So one is simplicity, and adopt the maximum potential of the environmental quality, environmental element into the design itself. The picture here is the picture of, I think, one of the palm species, in tropical palm species that we adopt in the roof design. And then as well as looking into the culture, and to create the identity of the airport. Right. Talking about environment, we were looking at making it naturally ventilated airport. I think large portion of it is naturally ventilated. We look at the precedent of the Jeddah Hajj Terminal by SOM, completed in, I think, 1981. And talking about identity, it is inspired from the Bedouin tent. So I think this is how simple the concept is. Right. And taking into all this information and digest all the information, we start looking into the design of the airport that I mentioned. Right. Basically, the first element or the first step is looking at the vernacular architecture within Malaysia or Southeast Asia. This is one of the building component of building topology in Malaysia. So the component of a shaded circulation area, insulated interior spaces, as well as the shaded and protected internal courtyard is something that can be adopted and in the airport design as well, because airport is a building, so probably whatever works in the vernacular architecture or other architecture might work in the airport as well, right? Okay, so looking at the layout, basically, it is very simple planning. The process area, and as well as one domestic wing and 2 international wing on either side. And basically, we were looking at the incorporating a lot of automation in at the processing area, so that because the idea of want to move the people fast, and then flexibility at the next stage, which is the security, immigration, scanning, and all that. So, and then, one of the flexibility that we try to incorporate here is combining the domestic and international at one location. The advantage of it is like you can share the resources and you can juggle the crowd. For example, when the domestic flights are more than international, you open up more counters for the domestic and try to adjust it. Adjust the movement accordingly. So this is, I think, the advantage. One example of being flexible or challenging the space planning. And of course, another component in the layout is create the different experience. I mentioned about automation in the process, as well as minimal mechanical intervention. I'll show later on how by adopting a passive design space planning strategy, you can actually minimal the mechanical intervention in for the people circulation in the airport. Right. This is talking about the experience. I think earlier one of the panelists mentioned about incorporating landscape design. I'm kind of quite glad people are talking about incorporating plants or landscaping inside the terminal building, because you create experience, and then of course airport is long, very long building, and so you have to experience a lot of other things while you travel. So this is the view looking into one of the international wings, and as you can see, it is a high volume space which is quite airy. This I mentioned about being naturally ventilated airport. This is like a huge pavilion with a lot of air movement between the spaces, and and then the space feel like a semi outdoor space with a lot of landscaping. And air conditioning only concentrated at the waiting lounge. Okay, for example, if you can see the spaces underneath these red bands are the waiting lounges. So basically, you are just focusing the air conditioning at the area where people sit and wait, and the area where people move, kind of like naturally ventilated. Okay, another challenge for designing airport is the long walking distance. How do you manage that? Okay, basically we manage it. We try to explore the possibility of creating different nodes, and by having different process that kind of try to mitigate the long walk. And so another thing is another way of managing this situation. What we did was tackle it at the aircraft parking base as well. So basically, you have instead of aircraft base in one rows that makes the building very long. So probably you stack it at a certain semi finger kind of situation layout. Right. So this is how we try to manage it. So basically, in between nodes, you are probably walking about 120 meter. IATA recommend to have a walk letter every 300 meter, if I'm not mistaken. So I think this is kind of quite a manageable way of trying to avoid having a travel letter and encourage people to walk within the airport terminal. And another thing is departure. If we always know that the departure always in the upper floor, and then you try to minimize the level change. Basically, if level change only happen for the movement of people from up and down, so that you can incorporate ramp in the design. And for arrival, normally you can just have one level out. So basically, there's no level change. Perhaps the transit passenger need to do a bit of changes, but then that is not the major component of not the many people are the transit passengers within this airport. Right. I mentioned earlier about I will focus a lot on the naturally ventilated area or naturally ventilated space. This is about 30%, only 30% of the area within the huge building is mechanically or air conditioned. So the rest are quite naturally ventilated, of course, with assisted air movement by industrial fan and all that. I have tried this in other big, huge buildings as well, and it works. I believe it can work in the
Mr.
airport.
Jaafar, sorry to interrupt you. We are running short of time, so if you can conclude in.
I will expect that. I think I'm almost there. So basically, so only 30% of the area is air conditioned, so it helps a lot. If you remember earlier about the HVAC, takes up quite a lot of energy in the airport. Okay, other low energy solutions are the controlled natural lighting. Of course, I mentioned about having good insulation for the roof, and cross ventilation I mentioned, and shaded thermal buffer. Air condition is kind of like shaded thermal buffer around the air conditioned area. And as far as the low rainwater is concerned, probably we can adopt the rainwater harvesting, grey water recycling, air conditioning, condensate water recovering, as well as the material. Obviously airports needs to have high performance glazing for the insulation, for the noise insulation, sound insulation, as well as heat insulation. And then the flooring, high thermal mass, because thermal mass will be shaded and kind of like cool down the space, cool down the ambient temperature in the building. And this is an example of the breathable outer layer skin that allow the air to come in, as well as prevent the rain from coming in. Okay, so I think another component is renewable energy. It from the roof can generate about 15 million kilowatt hour per year, and the pattern of the solar panel can resemble the one of the fabric in Malaysia, songket, if you are aware about the Malaysia. Okay, this is the last slide. Okay, we look at I talk about the different timing of the airport. The first full service airport, on the top is the KLIA. It is about the same 45 MPPA and designed for 45 MPPA with the future terminal, but currently it is only 30 MPPA because the terminal hasn't been built yet. It is a huge, bigger. The gross floor area is big because of it was catering for the probably wide body aircraft. A majority of the aircraft bay is for the Code E aircraft, and energy consumption is about 100 million kilowatt hour per year. This is because I take this as a benchmark. Even KLIA now, I think they have adopted a sustainable design approach, and the energy consumption has been reduced. Okay, but for this simulation, I just used this figure. Okay, for the proposed LCCT, it is smaller, about 250,000 square meter, but the capacity is the same, 45 million MPPA, and based on the KLIA energy consumption. This with the reduced JFA, the energy consumption is about 74 million. And with all the initiatives that we have incorporated earlier, perhaps the saving can be around 60% of the overall energy consumption if you compare to the baseline. And that, if you look at in different perspective, that will translate into providing energy for another 5,600 homes in Malaysia, actually, based on the Malaysian standard. All right, I think that's all, Prasad. Sorry, I take a lot of time. Right, thank you very much.